Hello everyone, I'm Xiaogan. Let's go ahead and set up this environment, but you'll notice there's something wrong here. What's wrong? After you consult, you'll find that at the engine level, one level above, there is a blank program, xp blank, xLagProgram. Obviously, we don't want it to look like this. So we did some work here in this target.cs file. Let's see if we can affect this area. So let's refresh this project here. Okay, let's reload it. Good, you can see after the reload is complete, we have a folder here, and it's right here. Now let's compile it again. Let's compile it. Then let's run it. Okay, we'll remove the breakpoint here. Okay, after execution, go to this folder. Let's refresh it. It's still here. Then this thing is not quite right. Actually, was it here before? We'll solve this problem later. Okay, you can see here we have this printed text. We can search for it. It should be hello. Hello world is fine here. Then we mainly need to look at this thing, this engine batteries, NG64. Here it has moved to this position. That's pretty good. Now we mainly need to think about, so this programs, it was originally in this location, but for some unknown reason, it has now been moved directly to this location. Obviously, we weren't here before. Currently, it is in this location. You see it here. There are also some configurations. This should be related to the engine. It might have thought it wasn't suitable to be placed here before. For example, like we are here, we found this old project. Let's build it. Then we run it. Okay, let's erase it. Then we come here. Come to our old epic. Then we are on a monthly basis here. In the scene, look at this place. It is breaking monsters. And then here, you can see there's a small login server version here. And also a slate for Look at this. This thing is here. So this is clearly the engine doing some work. We need to configure some parameters to adjust accordingly. Okay. I looked for it. Couldn't find it. How does he modify it? This program is the survival position. Then we won't worry about it. Anyway, the engine often makes such a path here. There are some things, the version does have changes. We won't do this. We won't worry about the details. This is where a task is placed. A score scope. It allows us to query later. Such a state, we won't worry about it. Then we delete it. At this point, we'll just follow our writing method. After placing a scope here, let's delete all of these. Now we're going to start writing from scratch. This code, first of all, after we enter, we first need to get our command line parameters. Then after the command line parameters, we perform a pre-initialization of the engine. Then after the engine pre-initialization, we let it execute this. Check if we have any U objects. All U classes, whether they are all registered. Default properties are all initialized. This function you see here must be called. After a module is added, then it contains, if it is a U class, then you must execute this thing. Then after executing the process, then that is to say, here we tell it, then start processing this. While added while such a class. You see, just like this, the code here. Actually, it is mainly copied from Slate into Unreal. After copying it over, we go and modify this program, declare it as this singleton type, this kind of application here. Then you will find this thing. If not, the reason it's not there is because we didn't include the same component. We'll just change it to include it once here. Let's be a bit frugal. We need to include this Slate reflection module. Then we need to include this Slate, this table module. And there are some other things. We'll just include them all at once. Okay. We'll handle the rest with a simple process later. Okay, so here we mean, anyway, just make a need to initialize a Slate rendering. You see, actually our editor program. It is a Slate application. Just that kind of thing. After the initialization here is complete, we just turn on the high resolution. This DPI. After turning it on, here we go confirm this module of the source code, whether it has been included or not. Then after the loading is complete, let's take a look. If on we need to confirm that here the OAS module has been added. This looks like common AS, code access, modules related to linkage. Okay, then after this processing is complete, we can set the name for our application. We set this name to get our application, then our place without this context, right? We need to take this context and supplement it for everyone. That is, we often need to do this kind of, when translating, we need to handle this context. So we need to write the context here. Then we write this too, then below here. Then below here, then this name we call shutdown. Then after having the context, then and then this apt title, it becomes like this. And then here, anyway, we need this code. This code is often used because sometimes we encounter this problem. That is, this module, it hasn't been loaded. It means you need to load module and check it. And here we pass in such a template, and here there is a this workspace menus developer value thing. So what does this actually? We just write it above. That is, we need to create a smart pointer to receive it. Okay, good. Actually, this part is about making that slick. Something like a reflector. Actually, these are not our main concern. Then next, we need to write code. Currently, we have nothing yet. We'll just frame it here. Hold it for now. Let's add a comment here, because it's not really suitable for me right now to write this code directly here. If it's okay, we can write it, no problem. So let's first write two namespaces. Two so big. These two are so big. They are mainly used for our window. We see these two are so big. We don't have this slate here yet, so we can just delete this part here. Then briefly explain what this so big is. It actually goes to insert such a parameter, then return a slate of type stalker. These two so big. What should we do? These two lambdas correspond to the two type tags we want. Then on this side, we get our global type manager. Then we register the first tag. Then we pass a lambda in the form of a lambda, and its name is this. Okay, no problem. Then we registered the second tag, and its name is calculate code lines. So it's like this. No problem either. Then we need to confirm that this slate reflex has indeed been loaded. We confirmed it again. After confirming, next we will start working on the layout of the entire page. So how do we do this layout? This code is actually like this. We get our table manager. We leave a layout. This layout is called this name. Then we will create an area division like this inside it. For the area division here, we use this method. We left-turn AR. This resolution is 1280 by 720. This window is like this. Then we use the select to continue a split. After the split, our part here is actually done. Then we take this thing and register this layout. Register it. After registration, our work here is actually finished. Then we can print a log here. Okay, let's print it in Chinese. Initialization complete. We'll call it init finish. Okay, let's look at the program log here. We should guess the name of this log. Good, initialization is complete here. Then we go get the core of this program call. Let's look at this core. This core should be defined by us, so we don't need to worry about it. This is our own code. We still need to actually execute it. Only then do we need to do it, so we don't need to do it now. This is just initialization complete. We still have a lot of work to do. Then at the very end here, we need to execute the engine pre-exit. Then we'll shut down the API casing, shut it down. Then here, we unload all modules. After the uninstallation is complete, We then execute the exit. Okay, now we can run this code. Let's compile it to see if there are any issues. Okay, now let's launch it. Okay, it's quite obvious because there is no negative loop. So we should use a wire2 here. Wire. It will just pop out directly. Wire. Okay, now let's execute. We can take a look. Now we are completely stuck, right? Yes, this freezing is also quite normal. The reason for the freeze is because we can just let it slip for a bit. Because this time is too long, let's make it sleep for a bit. We'll ignore the rest for now. Just let it sleep for a bit first. Okay, you can see currently there should be nothing, but it has actually already come out. You can see here, xgslamprogram. The reason it's not there is because we haven't actually finished writing this code yet. Okay, let's continue writing this code now. Then what should we do? Then right here, we should write it like this here. So we need to loop through it. Then for the engine here, if it hasn't exited, we go to the loop. If you want to insert, then this proves it has exited. If we come in like this, we check whether there is this exit command. If there is an exit command, then we start the exit, right? And here, we need to get our test graph thread. And then we let it process whether there is this task. And we need to do this here. If we use this test new year analysis, we can let it advance the firm. Advance one frame, I suppose. Yes, just do an evaluation. Okay, then here, we need to use this tester. Let it tick. Then we tick our core. Then we need to handle application. Does any such message pop up? Then application. We also let it tick. Finally, we increment our GFM counter by 1. Okay, good. So that should be about it. Then we don't want it to execute too quickly. We'll make it break for 10 seconds per frame. Now let's execute it again and take a look. Okay, then it appears. You can see. So in fact, we have created a window. This window doesn't have any of these things yet. Right, this part is not there yet. Then, next, let's explain the code. And we'll explain this code first. This part is set window. It's actually very simple. It just modifies the position where it appears. You can see that if we change it to 300 like this, you can see it appears slightly lower on the screen. You can see, right? If we change it to 10, you can see it usually needs to be compiled first. The position it appears is relatively higher, so this is a position. This is obviously the resolution. We change it to 1920 times 1080. Then it will definitely be much larger. Let me show you. Wait for it to compile here. Okay, you can see it is obviously much larger now. Let's revert this parameter for everyone. 1281:17:20. Okay, good. This place has two windows. These two windows, their style type is actually here. Is an open window. And this is one of its states. And here we let it display in the foreground. Is this modify? This is this technical interface. Yes, actually the engine has two types. This type, one is the mergeable type. The other is an independent type. It's this type. It should be this one. Okay, remember. Okay, these are all minor details. We don't need to force it anymore. Then at this point, we will guide everyone through this code. Actually, you don't need to worry about the stuff above and below because it's related to the engine. Because the engine does it this way too, and they are all fixed. This convenience is that we get start from Windows, get this command line, then we pick some modules we want or some things to handle. After finishing the handling, then it really comes to us. After it comes to us, we go. This later part is when we get to our how. We need this code. Then we want several windows. We do it right here. Perform a split and division. So we first apply for a layout. After applying for this layout, there are 2 of these tabs. So we will take this command for generating the tab and put it in. And now it's empty because this S6 is just to create a canvas, like a blank slate. After that is done, there are some registration commands here. Then we let it restore the registration. So this window is done. Once it's done, we log out that plate, right? Then this place is just a continuous loop. Just process these asynchronous tasks. Then we pop up some information and such. Then we remember we need an increment each time. This kind of information. Okay, then finally we have an exit. First exit, then close our application. Then finally load. Just exit the module. Then finally the engine truly exits. Okay, so the entire such Slate standalone program framework is like this. Everyone can see. Then our next task is actually quite clear. We just need to implement the functionality we want. Right now, we have essentially completed the front end. And for the underlying core functions, business logic calculations, we haven't actually written them yet. You can design some buttons in the interface. In the previous slide, we showed you dynamic images. So can you? You could even use it to make an audio-video player, and its efficiency is extremely high, reportedly reaching several thousand frames per second, 8,000 frames. That kind of level, because it doesn't have this rendering thing. Right, okay, it's just very fast. And if you want to see how fast it is, you record a time here. You get a data time, then do a time decrement, then use 1, and then invert it. You'll know roughly how many frames there are in 1 second. This efficiency is extremely high. 1. After we finish explaining, we'll add a bit more code for everyone. We can also launch another window here. Let's see where we place the startup window command. We put it here, and let's execute it. You can take a look. You can see after we execute it. Look, there's an extra window here, right? This window actually has some issues here. Let's ignore it. This window here is actually executed like this. You can see a window is added here. The size of this window is like this. If you want to create multiple windows, then you can do it this way, but we don't need it. So I'll just comment it out here. If you want to know how to use it, just copy it from the source code. Then next, actually at this point, we are not registering a thing called flag tester. So we release this thing. This part is a chain programming style because you notice that this add-all will also return such a pointer. And then we can do this. We put it here. We do the code like this so that it can connect properly. Then let me show you what the result looks like after execution. You can see what this is. What this is. Isn't this thing very useful? Have you used this in Blueprint? You can see it can help you do some analysis, right? That is, what exactly is this thing? What is its Slate architecture like? Of course, this course will not cover Slate. It goes too deep. So just know that such a thing exists. Let's comment out this piece of code. And if you need it, you can refer to it. Let's comment it out. Okay, so this lesson ends here. We have set up the basic rendering framework of an independent program Slate for you, and how some code inside is called, why calling it this way is relatively complex. You can study it later. Okay,